Good morning, friends. This is Gopi Palla, student of IIT KZP, and today we are going to discuss a topic on time and work, and which is more important for the competitive world, for cracking any bank jobs, or for any career-oriented interviews or entrance examinations, and for ease of calculating or for ease of practicing. I have taken this part from the RS Agarwal, which is famous for quantitative aptitude. And in this, we are going to cover four. This is very pretty easy to learn because this is very practical in nature, and we can easily understand, and we can easily execute them. We can easily calculate the problems. First, there are three important rules are there for which are behind the calculation of time and work related problems. If you remember these three rules for by solving the problem, then it is very easy to learn and solve the problems. And for example, if a person A is cutting a tree, and if it takes n days to complete the work, and if then 1 day's work is denoted as 1 by n. So for example, if n is 10 days to cut a tree, then A's 1 day's work is 1 by 10. Conversely, if as per rule 2, if you can define as a rule 2, then if A's 1 day's work is 1 by n, then A can finish the work in n days. That is, A's 1 day's work is 1 by 10, then A can finish the work and is equals to 10 days to cut the tree. That is called rule 2. The third rule, which is pretty simple, that is, if A is twice as good as workman as B, then the ratio of work done by A and B is 3:1, because A is thrice good means his capability to work is 3 times better than B. So from the circle we can see that if A occupies 3 shares and B occupies 1 share, obviously this time taken to complete the work is 1:3, because A is 3 times better than B, so A can complete faster than B. That is inverse ratio 1:3. The problem of time and work can be more easily understood by solved example of R.S. Agarwal. So I have taken the first example, which is pretty simple to understand. That worker A takes 8 hours to do his job, and worker B takes 10 hours to do the same job. How long it take both A and B working together but independently? Means A's work is not affecting on B, and B's work is not affecting on A to do the same job. So here means from A rule 1, whatever we have studied, A's 1 hour's work is 1 by 8. So similarly, his 1 hour work is 1 by 10. That is as per rule 2. So we need to calculate that both together, means A plus B's 1 hour work is the summation of 1 by 8 plus 1 by 10. So we know that how to calculate the ratios. That we have to calculate first LCM of denominators, that is 10 and 8. Then LCM resulted value 40, and if you calculate numerator and denominator, if you divide denominator by 40 by denominator of first fraction, and 40 divided by 10 by second fraction, then you can get the value is 9 by 40. So we know that this is the A plus B's 1 day's work. So A plus B's, how many days they can finish the work means we have to invert it. So 40 by 10 as per rule 2, as we know already. So now we are going to the example 2. Example 1 is pretty simple of summation of joint work. Example 2 is different, which is A plus B together can complete. If A plus B together can complete the piece of work in 4 days, and if A alone can complete the same work in 12 days, in how many days B alone can complete the work? So here they have given total work done by, if A and B together, 4 days. So A and B's 1 day's work is, as per rule 1, is 1 by 4, and A's 1 day's work is 1 by 12. We need to find out the B alone how many days it will take to complete the work. We know the total, we know the one person's work, so we can calculate. So a plus 1 by subtracting the total work from A's work. So that is 1 by 4 minus 1 by 12. As we know that LCM of 4 and 12 resulting in 12, and we now have to calculate the resulted fraction is 1 by 6. And but the answer is not the B's 1 day's work. Answer is how many days B alone can finish the work. So that is as per root 2. It takes 6 days to complete the work. B alone if he is carrying out. Thank you.